All right, here we are, 4.2D. We're in chapter 4, systems of equations. 4.2 tells us to solve systems of equations using the substitution method. And here's our D video telling us showing us how to use the substitution method on a system which has two lines that are the same. And what's it going to look like? So we're going to go through the system of equations substitution method steps. Step number 1 in the executive summary, I guess, is solve one equation for one of the variables. In this example, it's solve for x. X equals something. And then you take that something and you solve that or replace that something into the other equation. So that what you solved for goes into the other equation for x. Then you'll have an equation with just one variable, and that'll be y. Solve for y. And then you'll have y equals some number, and that'll be your solution, half of your solution for the system, but your solution for that line. And then you go back to use that y equals a number, and you replace that value into either original equation, and you solve for x, because you'll have just x terms and constant terms, and you'll just solve for x, and you get x equals a number. And there's your solution. You can double check that solution in both original equations. All right, so there's our step-by-step solution. So here, we're going to solve this system of equations. So step number 1, it says we have to solve one equation for one of the variables. I'm going to suggest probably solving b for y, because by doing that you'll only have to divide by 2. And when you divide that by 2, it's a whole number. When you divide that by 2, it's a whole number. So let's take b and kind of work with b and start with 12x. Start with 12x plus 2y equals negative 2, and say let's solve for y. We're going to subtract 12x over here, subtract 12x on the right side also. And we've got 2y equals negative 12x minus 2. Now divide by 2 to get just y by itself, because that's part of the substitution method. We have y equals negative 12 divided by 2 is negative 6. We've got an x in that first term. Second term is negative 2 divided by positive 2 is negative 1. And there's our y equals. And we take that value for y and we substitute it into equation a. So we start by writing a down and say 2x plus 1/3 y equals negative 1/3. And all I'm doing is just copying this right down here. So I can now substitute this in for y right there. So let's keep writing, and I'll write that as a. Let's keep writing what we know, 2x plus 1/3, and we know that y is negative 6x minus 1. And we keep rewriting whatever is left over. Now we just solve this Christmas equation for x, because we've got just x terms and constant terms now, so we just keep rewriting. 2x plus 1/3 times negative 6x should be positive times a negative is negative. 1/3 times 6 is 1/3 of 6, is 6 divided by 3 is 2. We've got the x in there also. Next term is 1/3 times negative 1. Positive times a negative is a negative. 1/3 times 1 is 1/3. Equals negative 1/3. That's the easy part on the right side. Now we combine like terms, because we've distributed right here, and now we've got nothing in parentheses, and we just simply combine like terms. 2x minus 2x is 0. Minus 1/3 equals minus 1/3. So right there, we can say, well, you know what? Minus 1/3 equals minus 1/3, or negative 1/3 equals negative 1/3, means that we have same line. And I guess if I were you, I would say, you know what? Before I know that these two terms, the 2x minus 2x, cancel out, which they do according to this, I would go back and double check, just to make sure, because you've got to double check anyway. So start with your assumption of modifying your b line and say, well, did I modify that correctly? I started with copying down correctly. I moved the 12x correctly. Is this 2y equals negative 12x minus 2? Divide by 2 is, that's correct. That's correct. That's correct. All right, so that one is correct. Let's see, now did I copy this down? 2x plus 1/3 y equals negative 1/3. Yep, sure enough, I copied that down correctly. And now did I substitute incorrectly? 2x plus 1/3 y is negative 6x minus 1. Yep, equals negative 1/3. All right, so far so good. Did I distribute correctly? 2x plus 1/3 minus 6x is minus 1/3 of 6. 1/3 times 6 is 6 divided by 3 is 2. Yep, the x is there. Positive times a negative is a negative. 1/3 times 1 is, yep, that's correct. And then 1/3, all right, so far so good. And then I just combined these two like terms, and sure enough, I got to negative 1/3 equals negative 1/3, and that is a situation where if you get something like that looks like this, negative 1/3 equals negative 1/3, or 3 equals 3, or 12 equals 12, or 0 equals 0. Because you could take this to the next level and say, well, let's add 1/3 to this side and add 1/3 to this side, and you get to 0 equals 0. That would also mean that you've got the same line. Now, if we know that if we get to something like negative 1/3 equals negative 1/3, then that means that it's the same line. Why does it mean it's the same line? Well, if we put each of these into the same format, let's see, we could, take our A line and say, let's modify it to put it into y equals mx plus b format. 2x plus 1/3 y equals negative 1/3. Put it into y equals mx plus b format. Slope-intercept format, so we can kind of combine or compare the two lines so that we know that they're the same. X's have to go to the other side, so we subtract 2x, and say that 1/3 y equals negative 2x minus 1/3. Now we'd have to multiply on the left side by 3, or multiply by the reciprocal. So multiply by a 3 over 1, because 3 over 1 times 1/3 gives us just 1y on the left side. Now we also have to multiply everything on the right side by 3 over 1. So negative 2x times 3 over 1 is negative 6x. If we're distributing that 3, negative times a positive is still a negative. 1/3 times 3 is 1. So slope-intercept form for the red line is y equals negative 6x minus 1. If we look at the green line, and this is just for edification purposes, 12x plus 2y equals negative 2, that if we graph these should be the same line because we see that they're the same line down here. How would we do this? We double check by subtracting 12x on each side, 12x on each side. Oh, and you know what? We've done this already. We've got this over here, y equals negative 6x minus 1. Because we've modified this to solve for y. In fact, we've done this already. So in the red line looks like y equals negative 6x minus 1 in slope-intercept form. The green line looks like y equals negative 6x minus 1 in the green line. So the green line and the red line are the same. And what does it look like when we use the substitution method? This is what it looks like right down here. Some number is the same as some number, or 0 equals 0. Don't confuse it with x equals 0. When you see x equals 0, that's part of a solution. That would be part of a solution. In fact, I'll put that in black and say, oh, you know what? If you get to x equals 0, don't say that, oh, that has to be the same line because 0 equals 0. When you get to x equals 0, that's a value for a system, and that would be a completely different system. But when you get to x equals 0, that means that that's a solution. It doesn't mean that it's the same line, all right? So when you get to a number that says 0 equals 0, that's the same line. Negative 1/3 equals negative 1/3, same line. X equals 0 means you've got some solution, 0 and some other y that you've got to solve for. So make sure that you understand that situation for same line solutions.